Collapsing electric power grid reliability and economics. We're going to shift gears to an increasingly important perspective. CO2 concentration, which is one of the two major challenges now facing our power grids. The other, of course, is traditionally the operational maintenance and maintainability service schedules and business economics of each state's power grid demand response. States are quite jealous of being able to provide power to their state. The federal government seems to be eager to take this over, but the states constitutionally have that responsibility primarily. So, looking at the bottom chart you see, this is a chart of actual measurements of ice core data going back 800,000 years. In those 800,000 years, CO2 oscillated from 175 to about almost 300 parts per million. We don't know why that oscillation or how that oscillation took place. But shifting to the upper screen, we know that global CO2 has increased as of this year to 419 parts per million. It annually peaks in May and follows a kind of a sawtooth general pattern. As CO2 increases, more heat energy is trapped in the Earth's atmosphere, warming the planet. But there are 1,000 other events that follow closely biophysical attributes of this CO2. Now, going forward one screen, hey, to the great global conveyor. This is being furiously updated, our understanding of it, in particular, the Atlantic meridional overturning circulation. Looking at this great global conveyor, you'll see that it collects most of its energy in the Pacific, which is the largest ocean and major collector of the sun's heat. That surface heat drives the global conveyor in this simplified chart. Surface water currents are in the red, deep water currents are in blue, and bottom currents are in purple. As you know, warm water rises, cold water sinks. But the conveyor is a thermohaline-driven ocean current, meaning the sea's water temperature and salinity determine its density, which is why the salinity is shown on here. And it's an important critical aspect because as the hurricanes, for example, grow out of the South Atlantic and strike, for example, the US, the rain makes the salinity of this ocean conveyor or Gulf Stream, which is the part going by the United States, makes that salinity go from the normal green to a lower salinity of about 34% as it goes up toward the north and south poles, which is where that heat goes to meet the cold at the north or south poles. Half of that current arrives down there, and as you can see in those two yellow dots in the deep water formation, those two dots or regions in the Antarctic and in the Arctic up north are where the critical mixing takes place, and that red current sinks. This in the east and west sides of Greenland is where the Atlantic meridional overturning circulation takes place. In recent years, a warm area has been forming and is now formed, which is changing our circulation and slowing the Atlantic meridional overturning circulation. So the Arctic part is constrained where the Asia and North American continents almost touch. So that Arctic Ocean mixing areas on that area are much smaller. It translates into only the area east and west of Greenland. That's where most of this AMOC takes place. As the AMOC is slowing, it's bringing increased rain to the eastern U.S. from the increasingly warm ocean water, which is slowed in its circulation because of the increased heat which is resident in it. The western U.S. is most influenced by the California current, a slower and cooler current than the Gulf Stream, resulting in the western U.S. moving toward the reverse situation. California is number one in gross domestic product and population, bordering the cool California current. Texas, number two in GDP, is number one in power grid generation and demand, bordering the warm Gulf Stream, again, which is part of the AMOC. California has had record hot, dry, and fire-prone conditions. In July 2020, California's PG&E, America's biggest power company, emerged from bankruptcy again. 2018 was California's previous record year for wildfires, with 1.8 million acres burned, more than 100 people died, more than 17,000 homes and 700 businesses destroyed. In 2020, last year, California's fires burned 4 million acres, an area larger than Connecticut, surpassing the 2018 wildfire total, destroying 8,200 structures, displacing tens of thousands of people, killing 31. California has seen the most frequent, deadly, and costly blackouts in the entire U.S. in the last dozen years. Both California and Texas grids have had serious maintenance failures, preparing and responding to the climate or weather they expected. Both states had unusual and complex legal specifications specific to their states for grid control and responsibility, power grid ownership, transmission and distribution, which have been shifting, especially in California, and responsibility, corresponding to the maintenance, and finally power sales, which also had no financial interest in these other attributes. The wealthy in these states simply bought their own generation, including diesel generation or rooftop solar with large battery backup. Poor were subsidizing these net metered microgrids through power bills. In 2021, California, Idaho, Nevada, Oregon, and Utah had the hottest summers on record. Climate change is unleashing unprecedented wildfires, deadly heat waves, and drought conditions throughout the West. 16 other states saw top 5 warmest summers on record. Drought, bone-dry trees, brush, fires from lightning, failed maintenance, and elevated temperatures due to record-setting heat were blamed again this year. High temperatures lower the power handling rating of wires and connections, a key maintenance issue due to the failed maintenance. California requires 44% of their power sales be from renewable sources by 2024. California's deregulated segment sells electricity into the market during peak crunch periods, near dinner time, about 3 hours late in the day. California planned to seek most of that peak power demand from neighboring states, which were also experiencing peak demand. Turning to Texas, disastrous February 21 power outage, power companies typically keep about 10 to 20% of their power generation in reserve, normally, over and above anticipated demand for the day to prevent blackouts and disruptions both these states have experienced. In 2001, 1 year before Texas deregulation, Texas boasted a 25% reserve margin. But in the summer of 2019, Texas reserve margin sunk to just 7.5%. Blasted by winter storms and Valentine's Day 2021, as the chart shows, Texas demand soared to a winter record of 69,000 megawatts, then crashed, leaving more than 25 million people without electricity and wiping out cell phone service for weeks. Extreme record-breaking weather, Arctic weather, descended upon the central part of the nation and Texas during the second week in February, forcing power outages throughout this region. States in the Middle South were especially hard hit, notably Texas, where the extreme cold forced generators offline, resulting in a massive deficit of energy to serve customers during record winter demand conditions. Michael Schellenberger, speaking on bulk energy storage, which has been recommended for both Texas and California, stated that for Texas to receive 100% of its electricity from renewables, while electrifying all heating, transportation, and other services, would require 7,000 gigawatts of battery capacity to store the 13.6 terawatt hours of electricity needed. That would amount to battery power 6 times more than the entire electrical generating capacity in the United States. And the cost just for Texas would be $5.8 trillion, requiring 388 years of Nevada's gigafactory output. The system operator for most of Texas, the Electric Reliability Council of Texas, was forced to order unprecedented load shedding as a last resort to restore frequency and protect their system stability so that they can maintain any generation delivery. At its peak, 52,000 megawatts of all types of generation within ERCOT became unavailable, or 48% of all total installed capacity. ERCOT did this load shedding as the entire electric system was within a few minutes of total frequency and voltage collapse, necessitating the dramatic action they took. The crisis lasted over a week, ultimately subjecting more than 4 million Texans to localized blackouts. People were under boiled water mandates, millions more to a range of compounding impacts. Many municipal water systems failed for 14 million people. Natural gas deliveries were curtailed due to frozen infrastructure, with little to no dual fuel capability available for those Texas generation. Windmills froze and stopped generating reliable electric service essential to all critical infrastructure. Tragically, hundreds of lives were lost in the Texas crisis. One page I've got to change. So, why space solar power? Companies that collect bills from customers have no obligation in California to restore downed power lines because someone else owns them. Companies that promise lower power bills of wholesale power to customers in hopes of gaining market share, but don't shield them from soaring prices during a blackout, have little to no stake what had happened in Texas communities. Similar political games are being played in California. FERC and NERC have both asked for stronger weatherization standards for gas and electric sectors to avoid repeating the grid failures in Texas and the Midwest. Those with the same findings of the 2011 Texas freeze, which again translated into voluntary recommendations for power plant owners. More than 1,000 generator units were affected by that freeze. 57% of them were gas-fired units struggling to fuel their own plants. NERC says the cold weather extremes that happened in the South Central states in 2011, 2014, 2018, and now February 2021, the most extreme, especially in Texas, are no longer rare, as they were called during this most recent generation failure. State power grids failed to plan for and have no mandatory requirement to actually serve this changing seasonal and daily weather, chiefly because they don't have the generation alternatives necessary for the decades ahead. I've shown this chart before, so I'm just going to show you a few, such as this impressive list of authors from the Journal of Operational Oceanography. Again, this is researching AMOC. As you can see, there is considerable interest in this. This is the California references, Texas references, and some other references. I will give these to